Section 5.7, problem 25. We're still using the law of sines to solve and find what solutions for triangles are possible. So once again, we want to set up this problem using the law of sines. And the information we are given is angle A, so let's put that in one of these places. And then side A would have to go with that. And then the last piece of information we were given is side C. So then the easiest thing to look for then would be angle C. So go ahead and do your cross multiplication, as well as dividing both sides by 17.2, or you can think of it as just multiplying both sides by 12.2 to get sine of C on one side by itself. Then, just like in the previous example, go ahead and take the inverse sine of both sides before you plug anything into your calculator. That way your answer will be more precise. Alright, now we can plug this into our calculator, and we find that angle C, when we plug this into our calculator, is equal to approximately 42.7 degrees. Well, first we need to check and make sure that it's possible for the angle A that we were given and the angle C that we found to exist in the same triangle. Well, they add up to less than 180 degrees, so that is perfectly fine. Next, we need to figure out, is it possible for there to be a second angle C that could be a solution to this triangle? So if there is a second angle C, then that must be equal to 180 degrees minus the original angle C. So 180 degrees minus 42.7 gives us 137.3 degrees. Now, angle C2, 137.3 degrees, and angle A that we were given add up to more than 180 degrees, so then it is not possible for that to be a solution to this problem. So there is just one solution to the problem in number 25. So let's go ahead and finish out the rest of the problem. We now know that there's only one solution, and we know that angle C is 42.7 degrees. Well, the next easiest thing to find is angle B. Since we have 2 out of 3 angles, we just need to take 180 degrees minus the 2 angles that we already know. So then in this particular case, we find that angle B must be equal to, or approximately equal to, 30.1 degrees. And then as our final step, we just need to determine the length of side B. Again, use as much of your given information as you can. So in this case, when we go to set it up, we say sine of A, which is 107.2 degrees, over side A, which is 17.2, is equal to, and what we're looking for is side B, so we should use what we found for angle B in the remainder of this equation. So angle B we found to be 30.1 degrees. Okay, solve this for B, plug it into your calculator, and what you should get is that B is approximately 9.0 units in length. Now, additionally in this section, there are problems where the given information starts off with 2 angles. Well, if you start off with 2 angles, you can find the third angle very quickly using the same method that we've been using, taking 180 degrees minus the other 2 angles. So in this case, angle C is 80 degrees in measure. Now the nice thing about these problems then is that there is no ambiguity, meaning there's always one solution if you are given 2 angles and 1 side. So you can finish out the rest of this problem using the law of sines. In this particular case, you would want to set it up with sine of C over side C, because the only side that you know is side C. And then you could set it up either for A or B, doesn't really matter which one you find first. And then you would solve this equation for A. Similarly, you would solve an equation for B that would look the same on the left, but on the right you would have sine of 60 over side B.